And we're at lesson 5.8. This is solving linear equations using graphs. And your objective is to solve a linear equation graphically. Let's get started. Alright, graphs can be used to solve equations. Like before, we used algebra to solve equations. So if you look at this equation here, 0 equals 2x plus 2. Before, we've used algebra to solve this, where we would take away 2 from both sides and then divide by 2 and get x all by itself. Well, graphs can also be used to solve equations. Okay? So the graph of y equals 2x plus 2 can be used to solve this equation, 0 equals 2x plus 2. Alright, so let's look at this. If we were to solve this equation, again, we would take 2 away first from both sides. And I would get negative 2 equals 2x. And then I would divide by 2. And get negative 1 equals x. Okay? So I could solve that using algebra pretty easily and get this. Okay? Sometimes equations aren't as easy to solve with algebra, and they're actually easier to solve with the graph. So the solution, if we look at a graph, the solution to an equation is the x-intercept. Okay? So the point where it crosses the x-axis. Another name for the x-intercept is called a zero of the graph. And the reason for that, why it's called a zero, is because it's the answer where y equals 0. So like we look here, we have the line y equals 2x plus 2. This is the graph for that line. When y equals 0, the x-intercept is the solution. So the line crosses the x-axis at negative 1, so that's the solution to this equation if we were to solve it. And again, when we get going on later in the year, this is going to be a key concept to know. So x-intercept, in other words, is called 0, and that's the solution for an equation for the graph. Now we're going to go ahead and learn how to do these a little more. Here are your steps to solving a linear equation graphically. Okay, the first thing that we want to do is get the equation in the form ax plus b equals 0. So that just means whatever our equation is, we want to make 0 on a side by itself. Okay, because again, to solve an equation, we have to have the 0 of the graph. Then we're going to write the related function in slope-intercept form. So basically all we do is take the 0 and replace it with a y. Then we graph that equation, and then you find the x-intercept or the 0 of the graph. Alright, let's go ahead and look at this with a full example. Okay, this says write the function in the form ax plus b equals 0, then write in slope-intercept form. Okay, so again, this is our first two steps here to solving any of these equations with graphs. So first thing we need to do is get 0 on a side by itself. Well, basically what I want to do is make this right side equal to 0. So I just want to get rid of all this stuff over here. So the first thing I'm going to do is take away my x's and cancel those out. And I got to take away 3x over here, of course. So that leaves me with 2x's plus 4 equals 5. Now again, my goal is to get 0 on this side, so now I want to get rid of the other stuff that's over here and 0 this out. So I'm going to take away 5 from both sides again. And what happens, instead of canceling this time, we get 5 minus 5 is 0. And then we have 2x. And then 4 minus 5 is negative 1. So we got 4x minus 1 equals 0. Now we want it in the form ax plus b equals 0, so we're going to change our subtraction to addition. So there's the first step, is we've got the function in this format right here, ax plus b equals 0. So a times x plus b equals 0. Now we want to write it in slope-intercept form, so all we're going to do is replace this 0 with a y and flip things around. Okay, so I'm going to have 2x plus negative 1 equals y. And now we'll just flip that and put y equals 2x plus negative 1. Okay? Now this equation would be ready for graphing because we got in slope-intercept form. Alright? Okay, let's go ahead and look at another example. This says solve the equation algebraically and then check graphically. So the first thing they want us to do is to solve this equation like we normally would using algebra. So of course we change our subtraction to addition. Now we're going to add 5 to both sides. Get 2x equals 6. And then we're going to divide by 2. and get x equals 3. So the solution to the equation is x equals 3. What that tells us about our graph is that our graph should cross the x-axis at 3. Right here, that should be the x-intercept. So we're going to check that graphically using our steps we just learned. Well, first thing we do is put this in the form ax plus by equals 0. So we're going to change subtraction to addition. And we want 0 by itself, so I'm going to subtract 1 from both sides, because 1 minus 1 is 0. Negative 5 and negative 1 make negative 6. And I got 2x plus negative 6 equals 0. Now again, I'm going to write this in slope-intercept form. So now I'm going to take 2x plus negative 6 and set it equal to y. And we'll flip it around and make it y equals 2x plus negative 6. Now again, this is slope-intercept form, so we can use our graphing methods we learned in the last lesson to solve this. So, our y-intercept, okay, or first let's identify our slope and our y-intercept. Well, our slope is 2 over 1, and our y-intercept is negative 6. So now we can graph our y-intercept. We can go up 2 and over 1, and up 2 and over 1, and up 2 and over 1 again, if we want to. And we can see that this is going to cross at 3. So here's our checking graphically. We graph our line, and we make sure that our x-intercept on our graph is the same as our solution to the equation that we got. And it works out, that tells us. Alright, and let's go on to one more example. And now this example tells us to go the other way. They say to solve graphically and then to check our solution algebraically. So again, we want to get 0 on a side by itself, so we want to get our right side, whoops, sorry, let me erase that. Get our right side equal to 0. So we want to cancel out what's over here. So we're going to take away 2 x's from each side. And that gives us 0 over here. 4/3 x minus 2x, well 1 1/3 x minus 2x is negative 2/3 x. And we got plus 3. Now we want to write this in slope-intercept form. So we got negative 2/3 x plus 3, and we replace our 0 with y. And then we're going to flip it around. Y equals negative 2/3 x plus 3. Now let's identify our m and our b. Our m is negative 2/3, and our b is 3. Let's go ahead and plot our y-intercept. And now we'll graph this. We'll go down 2 and over 3. Pay attention to my scale here that I have. Okay, so we're going down 2, which will put us here, and over 3 will put us way over here. Okay, we could go down 2, over 3 again. We could also go up 2 and back 3. So for this one we'll do that. We'll go up here to where 5 would be, and over to negative 3. Okay, and then we will very carefully try to graph that line using a straight edge. Now you will see why Mr. Ayers wants us to use a straight edge, is to make this as exact as possible. Okay, it also shows you the problem with graphing is sometimes graphs can be inexact. Okay, so I'm not sure exactly where this crosses the axis. Alright, so I'm going to guess it looks like it crosses, well 4 is here, this would be 4.5. We'll say at about 4.75. Okay, or 4 3/4. So for my graph, I'm going to guess that the x-intercept is about 4 3/4. And we'll see how that compares with when I solve it algebraically. So we'll solve algebraically. Remember, when we solve algebraically, we want to get our x's all on one side. So to do this, I'm going to take negative 4/3 away from each side. And these cancel, and leaves me with 3 equals, and 2 minus 1 1/3 is 2/3. Now if I want to, I could multiply both sides of this equation by 3 to get rid of the bottom number. That'll give me 9 equals, and these cancel, and I get 2x. And if I divide by 2, I'm going to get x equals 4.5, or 9/2. And that's pretty close to what I thought it was to start with. If I would have been using a straight edge, then I'm assuming my graph probably would have crossed where I wanted it to, which would have been right in this region, right where this intersects here. Okay, so, but close enough. So what this shows us about graphing is kind of an inexact science, okay? So sometimes you're not going to be able to tell exactly what your answers are, but it is good for estimating and checking your answers. Alright, that's your tutorial, so good luck on your homework.